Hello students, today let us solve a problem on probability. The question says that a coin is biased so that it shows heads with a probability of 2/3. The same coin is tossed 3 times. Find the probability of obtaining a head, a tail and a head in this order. And the second subpart says that 2 heads and 1 tail in any order. We have to find the 2 probabilities. Now for any unbiased coin, any normal coin, if we toss a coin, we can get either a head or a tail. So the total number of possible outcomes is 2. For tossing of a coin, say let us make this as a rougher column. So total number of outcomes, let me write OTC, is equal to 2. That is head or tail. Now if we ask for a head, then head will be occurring only once in a particular toss of an unbiased coin. So number of favorable outcomes is 1. So number of favorable outcomes is equal to 1. So the probability of having a head in a particular toss of an unbiased coin is equal to half. That is the total number of favorable outcomes divided by the total number of outcomes. This is the same if we ask for a tail, because even then the total number of outcomes is 2 and the number of favorable outcomes is 1. So the probability of having a tail in a single toss of an unbiased coin is also equal to half. We know this, the sum of the 2 probabilities will also be equal to 1. So half plus half will be giving us a 1. But now this particular coin, this coin is a biased one, so that it shows heads with a probability of 2/3. 2/3. Therefore, the probability of having tails is 1/3 because the summation of both the probabilities will be equal to 1. So 2/3 plus 1/3 equal to 1. So the probability of having a tail will be equal to 1/3 in a single toss of this particular coin, biased coin. The same coin is tossed 3 times. Now these 3 tosses are independent of each other. These 3 tosses are independent events, because one event, one toss doesn't influence any other toss. They are completely independent of each other. Okay. Now let us proceed to solve the question. So this is our answer. Answer A for the first subpart. Now we are having a head, a tail, and a head. We have tossed this biased coin 3 times, and from the first toss we have had a head, from the second one we have had a tail, and finally we had a head again. Now we know the probability of having a head is 2 by 3, probability of having a tail is 1 by 3, and probability of having a head again is 2 by 3 again for this particular biased coin. And these three tosses are independent of each other. Therefore, let the first toss be designated as A. Second toss as B, and third toss as C. So these are the 3 independent events. So the total probability of these 3 tosses, that is A and B and C, the total probability, the biased coin has been tossed 3 times, so it is A and B and C. All the 3 events have occurred. So it is A and B and C. The combined probability is equal to the product of the probability of each individual tosses. So it is this. And what is the outcome from the first toss? It is a head. So in place of PA, we can write P of H. We can write capital P or small p, anything. So it is a head from the first toss, a tail from the second toss, and again a head from the third toss. So let us put the values. The probability of having a head from this biased coin is 2 by 3. This has been provided. And we have calculated the probability of having a tail, that is equal to 1/3. And this is again equal to 2/3. So we have the total probability to be equal to 4 by 27. So the total probability of having a head from the first toss, having a tail from the second toss, and again having a head from the third toss is equal to P of A and B and C, where we have represented A, the first toss by A, the second toss by B, and the third toss by C. So, and the 3 tosses have occurred. So it is A and B and C, and because all these have occurred. So the total probability, the combined probability will be equal to, it is the AND rule. It is the product of the probability of the individual tosses. So it is, we have written PA into PB into PC. And what is PA? That is the probability of having a head into the second toss. From the second toss, we are having a tail. So it is the probability of having a tail. And again, from the third toss, we are having a head. So it is probability of having a head. So now we are putting the values. For probability of having a head, we are putting 2 by 3, and for tail we are putting 1 by 3. And so 2 into 1 into 2 gives us a 4, and 3 into 3 into 3 gives us a 27. This is the answer for the first subpart. This is the answer for the first subpart. The answer is 4 by 27. Now let us come to the second subpart. Now they are saying that we will be having 2 heads and 1 tail. This biased coin has been tossed thrice, so we are having 2 heads as before and 1 tail, but the order has not been specified in this case. In any order, the total number of heads which will occur is 2, and there will be 1 tail. That can be in any order. So let us take, and again the tosses are independent of each other. Now, first toss equal to A, second toss equal to B, and third toss equal to C. We are keeping it as it is. So, what all sequences can we have? There will be 2 heads and 1 tail. How many sequences of heads and tail, 2 heads and 1 tail combination can we have? So the first one is given to us. This is head, tail, and head. The second option may be tail in the first toss and followed by 2 heads. And the third option may be 2 consecutive heads followed by a tail. These are the 3 sequences that we can have from the 3 tosses, which will be giving us 2 heads and 1 tail. This single tail can occur in the second toss, it can occur in the first toss, it can occur in the third toss. So these are the 3 sequences in which we can get 2 heads and 1 tail from 3 tosses of a biased coin. For any coin, we can have these 3 sequences of having 2 heads and 1 tail. The probability will differ because the coin is biased. Now, these 3 are 3 exclusive events, because the having of a head in the first toss, having a tail in the second toss, and a head again in the third toss is completely independent, and we cannot have this sequence and the second sequence or the third sequence simultaneously. All these are exclusive. The occurrence of one eliminates the possibility of occurrence of the other 2. So these 3 are exclusive events. So this combined, the probability will be in any order. Because they have asked for any order, we have to take all 3 of them. So the combined probability will be, if we put this as 1, this as 2, and this is 3, combined probability will be 1 or 2 or 3, because this sequence, the first sequence can occur, or the second sequence can occur, or the third sequence can occur. These 3 are exclusive events. The occurrence of any of these 3 completely eliminates the possibility of occurrence of any other of these, the other two sequence. So this is the OR rule. This is equal to P1 plus P2 plus P3, because they are exclusive events, so their probability will be added together. Now, for each individual sequence, we have P1, that is this one, head, tail and head, this sequence. This sequence is the same as this one, head, tail and head. Again, these are independent events, so they will be multiplied together, and we have got the probability of this sequence. So again, let us write it again. So P1 is equal to, since these are independent events, therefore their probability will be multiplied together. Let us write it. This is PH into PT into PH. This is the whole probability of the first sequence. Plus, now P2. What is P2? First is tail and the following two tosses gave us two heads. So the probability of having a tail is 1/3. So it was, let us put the value afterwards. First of all, it is PT into PH into PH plus, it is head, head and tail. So it is PH into PH into PT. So this is equal to, now let us put the values. PH is 2/3 into 1/3 into 2/3. Plus PT is 1/3 into PH is 2/3 into 2/3. Plus again 2/3 into 2/3 into 1/3. So this is equal to 4/27. We'll be having 4/27 for the second case and the third case as well. So it is practically 3 times 4/27. So let us write 3 times 4/27. So it is 4/9. So the answer for the second part is 4/9. For the first part, it was 4/27 because in the first part we have dealt with one single sequence, and now we have dealt with 3 orders because only these 3 orders can be possible. And the total of all this, the final probability of all these three combined sequences is 4 by 9. So our answer is 4 by 9 for the second part. That is, having 2 heads and 1 tail from 3 tosses of a biased coin in any order. The answer is 4 by 9, where the probability of having a head has been given to us as 2 by 3. So we have deduced that the probability of having a tail will be 1 by 3. Thank you for hearing.